In this video, we're going to look at the first step on how to solve first order differential equations. And we're going to start with the recap question. Okay, so it says the curve with gradient function dy by dx equals 3x squared plus 1, passes through the point 1 minus 5, and then we're just asked to find the equation. So this was stuff that we've done in first year. And essentially all we have to do, if you think about it, if we've got the gradient function but we want to go back to the original equation, like when we're asked to find the equation, we basically want to get back to y is equal to some sort of function of x. Clearly we just need to integrate this, don't we? Now, you would have just, I'll show you what they've done, you'd have just integrated the left hand side and you think, well, if you integrate dy by dx, you just get y. And then you'll integrate the right hand side and you'd get x cubed plus x plus a constant. And that's fine, okay? For the questions we're going to be looking at in this video, the differential equations, by the way, when we say a differential equation, we just mean any equation with a derivative in. So that there is called a differential equation because it's got a derivative in. It's a first order because it's got a first derivative, okay? Some of the equations we're going to look at, we won't just be able to integrate straight away. Okay, so I'm going to think about this in a slightly different way, and we'll still get the same answer. The technique that we're going to use is we're going to use separation of variables. So see that dy by dx, we're going to treat it like a fraction. And we're going to multiply up by the dx. So we'd have 3x squared plus 1 dx. And then we can integrate both sides. So we've got the x's on one side with the dx, and we've got the dy on its own. And sometimes we'll have y terms with the dy, but for this first one, we've just got dy on its own. So what is in that integral? The coefficient of dy is 1, isn't it? So we're integrating 1 with respect to y. And if you integrate 1 with respect to y, you just get y. And then if we integrate this stuff with respect to x, we'd get x cubed plus x. Now we have integrated both sides, so you might think we need a constant on both sides, but remember a constant is just a number in our equation, and if we put a number on that side and we put a number on that side, it would just become a number, so we only need one constant when we do this, okay? And then once you've integrated, obviously you just substitute in to find the constant, so if y equals minus 5, when x equals 1, we end up with minus 7 equals c, so our final answer would be y equals x cubed plus x minus 7. So this new little extra step here, where instead of just integrating straight away, we get the x's on one side with the dx and we get the y's on the other side with the dy, is the technique that we're going to look at in the next few examples. And the technique is just called separation of variables, because you split up the x's, split up the y's. And that's key step here, is how we're going to solve some more complicated differential equations. Okay, so our first example says find the general solution of dy by dx equals 4xy. General solution, just while you're getting used to the terminology, essentially means that we're going to still have a constant in our equation. Okay, so we haven't got enough information to find the exact solution. That'll come in the next part of the question. Now, if you look at the question we're given, clearly it's a differential equation, dy by dx. We can't just integrate this straight away. Like, imagine if you just tried to do what you did last year, where you just integrate and you go, well, that's y, and then I'm integrating that side. You've got a function of x and y. So the first step that we have to do is, I always think about it as we need to multiply by that dx. Okay, so the dx is going to be on the right hand side, the dy is going to stay on the left hand side. You can, with a bit of practice, you'll be able to do this in one step, but let's just do one step at a time while we first do this. So I've multiplied up by the dx to get the dx on this side. And then you look at this y term and think, well, how am I going to get the y on the other side? You pretty much always, when you're doing these rearrangements, you're going to be using multiplication and division. Okay, you divide both sides by y to get rid of the y on the right hand side. You couldn't just subtract it on the other side, that wouldn't work. So we divide by y and we'd be left with 1 over y on the left hand side, because that coefficient there was 1, wasn't it? So if we divide by y, we get 1 over y, and dividing by y on this side, it cancels. So we've got 4x dx. Once you've got to this point where you've separated your variables, x is with dx, y is with dy, then you can integrate both sides. we're integrating with respect to y, we're integrating with respect to x. Okay, so obviously this now is going to test all the integration techniques that we've been looking at in the last few videos. Integrate fraction, derivative on top, 1 over y becomes ln y. Right hand side, add 1 to the power divided by the new power, so that would become 4x squared over 2, so I'm going to write it as 2x squared plus c. Okay, very important that you remember plus c on this question, because we've got to find the constant in the next part of the question. Okay, it just says find the general solution. It doesn't tell us what form to write it in, so we could rearrange this. Quite often in the exam it will tell you to like leave it in a certain form. I suppose if you look at the answer on the handout, actually what they've done is they've taken the exponential, because they've got it in the form y equals a function of x, and it's actually a really important example, this one, because it's a very big mistake that a lot of people make on this. You know that if you want to get y on its own, to get the inverse of ln is the exponential. But what a lot of people do incorrectly is they take the exponential on the left hand side, and then they take the exponential on the right hand side, and they write e to the 2x squared plus e to the c. That is complete nonsense. Like, please do not do that. You need to understand that when you apply a function to one side of the equation, you have to apply it to the whole of the other side of the equation. Okay, so we would be left with e and ln cancel because they're inverses, so y would equal e to the power 2x squared plus c. So the exponential would have to be the whole thing. You may see it go one step further as well with this question, because if you think about how indices work, if the power is two things added together, so say for example if I did x to the power b times by x to the power a, that would be the same as x to the power b plus a. Just by using our laws of indices, when you multiply two things, you add the powers. So we could reverse that process. If we're adding the powers, that would be the same as e of 2x squared multiplied by e to the power of c. You might think, why am I bothering to do that? And when we get deeper into this topic and we do more exam style questions, it's a really useful technique to write that there separately, because e is just a number. Like, don't forget, e is a constant. It's like 2.71 28, and c is also a constant. So that there is actually just a constant. And quite often, I'm not quite sure why they use the letter a, but they would actually write that as a, and then e to the power 2x squared. So if it was like a show question, you'd probably see the answer written like this at the end. Okay, so the second part of the question says, given that the curve passes through the point 2e squared. Now, when you get a question like this in the exam, you should just realise that that information there we're going to use to find our constants. Okay, now in this case our constants, because we've rearranged it, is just a. Alright, you don't have to do that rearranging, you could have just subbed it in straight away, but because the question's split up, we will sub in to find our constants in this form. So if y equals e squared, and x equals 2, 2 squared for 2 times, so that'd be e to the 8 by substituting 2 into that side. So if we want to figure out what a was, a would equal e squared divided by e to the 8. A would equal e to the minus 6. So therefore, y would equal, oops, e to the minus 6 times by e to the 2x squared. I suppose with this one being an exponential, we could actually go back and put them back together. So that would be, if you add these two powers, e to the 2x squared minus 6. Okay, example 2, I'm going to do it all in one go so we can go a bit quicker. We're given dy by dt is equal to y sine t, and we know that y equals 50 when c equals pi. One thing to be very careful of, obviously, just make sure you're in radians. honest answer, if you're doing any sort of integration or differentiation, you have to be in radians anyway. Alright, but obviously because it's pi, we know we're in radians anyway. Okay, so how are we going to approach this? We're given a differential equation, we've got t's instead of x's, but that's not a big deal, is it? Separating, we clearly want the dy on the left, the dt on the right. If we multiply both sides by dt, and divide both sides by y, and then we can integrate. Don't skip this step because it's like a method mark in the exam by showing that you've separated the variables. And then we'll get ln y is equal to, just be careful, we're integrating, so we go anti-clockwise, so sine integrates to minus cos t plus a constant. Okay, my advice would be, if this question was all answered in asked in one, once you've integrated, as soon as you've integrated, find your constants, because you're going to get the method mark for doing finding the constants. If you rearrange and make a mistake, you can get into a bit of a mess and lose some marks here. So I would, as soon as I've integrated, let's find the constants. So we'd have ln 50 would equal minus cos pi plus c cos of pi gives us minus 1, so that would be minus 1. So we've got ln 50 minus 1, so that'd be plus 1. So subtract 1, we'd get minus 1 would equal c. So once we've found our constant, be very careful here, guys. You've got to sub it back into the current line of your working out. Okay, you might end up doing some rearrangements and then you think, oh, my constant's different to yours. Like, the constant has to go into the whatever values you subbed into, you have to go back and put it back into that line there. So we've got ln y would equal minus cos t plus our constant, which would be ln 50 minus 1. Okay. If you look at the sheet, we've got it in the form y is equal to. Okay. What I would probably recommend with this one, because it's going to be a bit messy, like, you can take the exponential straight away, and with a bit of practice that will be fine. But if I was going to take the exponential, I'd have like 3 terms. Now remember, I've got to take the exponential of all that stuff. So what I would probably be more inclined to do, if you get multiple log terms, group the log terms together first. So you'd have ln y minus ln 50, and then you could write that as ln y divided by 50. And then when you've got a single log term, you can just take the exponential on the right hand side because it's the inverse. So you'd have y over 50 would equal e to the power. Remember, you take the exponential of everything, minus cos t minus 1. So your final answer would be y would equal 50 e to the minus cos t minus 1. Okay. So example 3, we've got dy by dx is equal to 3 cos 3x divided by y, and we're going to first of all find the general solution in the form y squared equals. Remember, in the exam they will normally give you the form that you're aiming for. Okay, so if we start by separating the variables, the dy on the left, the dx on the right, multiplying up, we're going to have 3 cos 3x, multiplying by y, we're going to get y on the left hand side. So if we integrate both sides, we'd get y squared over 2. Again, be careful when you integrate. Cos integrates to sine, and remember, we are dividing when we integrate because we divide by the coefficients. So it would be 3 sine 3x divided by 3 plus c. So we'd end up with y squared. They would cancel, and then multiply up by the 2, so you'd have 2 sine 3x. A constant times by 2, you can just write a different constant if you want. Okay. And the point that we're given is 0.5 pi 2. So when we substitute that in, we'd get 4 equals 2 sine 3 times 0.5. Make sure you bracket your angle when you're doing this on your calculator if you need to. So that would be 3 times 0.5, so that would be 3 pi over 2. Plus this constant that we're trying to find. So sine of 3 pi over 2 would be minus 1, wouldn't it? So that would become minus 2. So that becomes 6. So therefore, y squared would equal 2 sine 3x plus 6. Example 4, we've got dx by dt is equal to xt plus t. Now just be really careful with this. We're actually working with two separate terms here. Maybe pause and just have a little think about how you're going to split this one up. Okay, so you definitely do not want to like start subtracting terms. Imagine if you subtracted t, you'd have minus t plus dx by dt, and you'd be like, what is going on there? Okay, remember what I was saying, you need to use multiplication and division to separate these. So you could spot that on the right hand side there's a factor of t that we could take out. And if you take a factor of t out, you're left with x plus 1. Okay, so we're going to divide both sides by x plus 1. And if we divide both sides by x plus 1, we'd have 1 over x plus 1 with the dx, and multiply by the dt, you'd have t dt. Then you can integrate both sides. Okay, integrating this fraction, derivative is 1 on top, so we've got f dash over f. That's going to become an ln, isn't it? So we'd get ln modulus x plus 1 t squared over 2 plus a constant. And does it say to write it in a certain form? No, actually on the sheet it leaves it like that, so I'm going to leave it like that. Okay, part B gives us the coordinates x equals 0, t equals 4. So we'd have ln, if you substitute 0 in, you've got 0 plus 1, so ln of 1. Don't forget guys, ln of 1 is equal to 0. So that would just become 0. 4 squared, 16 divided by 2, so that would be 8 plus c. So 0 on this side, subtract the 8, minus 8 equals c. Therefore ln modulus x plus 1 would equal t squared over 2 minus 8. And we have rearranged this to get it in the form x is equal to a function of t. So if we are going to do this, we will have to take the exponential. So we'd have x plus 1 would equal the exponential of the right hand side, which would be t squared over 2 minus 8, and then subtract 1. Okay, I think we've got one more to go after this. Last example is the first time we've seen like a modelling style question, so we've got a context involved. Please read the question carefully, maybe pause it first. Okay, so we've got a lot of information here, and if you do get a question like this, you need to start to pick out the key information. The first sentence you might skip over, but it's really important. It says a pond is initially empty. So that's going to give us our initial condition. Like I know initially means that when time is equal to 0 and when it's empty, the depth, which is x, is equal to 0. That must be read carefully. Fill gradually after t minutes, so t, the time is measured in minutes, make sure you use the correct units. The rate of change of depth, so when you get a rate of change, remember that's going to refer to a derivative. So you've got a rate of change of depth, and x is measured in meters. And then the final question says so the actual question says find x in terms of t. So what we're aiming to do, potentially for like 8 marks, maybe more, is to get x is equal to some sort of function of t. Okay, so let's not panic. Start by thinking about what we've got. We've got a differential equation. What do? We separate the variables. Okay, so with the dx on the left hand side, this bracket here, this is our x term, isn't it? It's 4 plus 5x, that's the power of a half. So I need to divide by this. So on the other side, it would be 4 plus 5x to the power minus a half, because we're dividing by that x function. We've got this divide by 5, and you can, if you want, you could multiply by 5 on the left hand side. When you get a constant in your equation, you can put that wherever you want. If you leave it on the left hand side, it's going to be a fifth. Like I wouldn't leave it inside the fraction. I would think about it as a number with the number as 1/5. So you can put it as a times by 5 on that side, or you can leave it as a 1/5 on that side. This bracket, 1 plus t squared, it's a linear function, isn't it? It's a linear bracket to a power, so we can do like a reverse chain rule. So I'm going to write that as 1 plus t to the power minus 2, and that would be with the dt. So the only real option is where you put this 1/5. You could put it as a 5 there or a 1/5 there. It doesn't really matter. Sometimes it makes it a lot easier if you leave the constants on the other side. And you'll see that when you do some of the exercise questions. Okay, so integrate the bracket to a power. Add 1 to the power, so we get a half. Divide by the new power, divide by a half. It's the same as times them by 2. The coefficient is 5. Remember, whenever we integrate these linear functions, we divide by this coefficient. So that would be divided by 5. I've then got 1/5. Okay, our bracket, 1 plus t. Add 1 to the power, so it becomes minus 1. Divide by the new power. The coefficient is just 1, so we're dividing by a 1 as well. We need the constants. I'm going to put it on the right hand side. Doesn't really matter where to put it. Okay, let's tidy this up a little bit and then think about maybe finding our constants. Remember, we're aiming to get x is equal to a function of t. So we've got 2/5, 4 plus 5x to the half. That would become minus 1/5, 1 plus t to the power minus 1 plus c. So at this point I'm going to sub in and get my constant. So if t equals 0, x equals 0, we've got 2/5. Sub 0 in for x, you get 4 to the power of a half, which is just 2. Minus 1/5. Sub t is 0, you've got 1 to a power, which is clearly just 1 plus c. So we've got 4/5 minus, so plus 1/5, which is 5/5, also known as 1. So okay, so we know c is equal to 1. Remember what I said, once you found your constant, sub it back into the line that you were working, so we end up with 1 here. Okay. Now we've got to rearrange this to get x equals a function of t. So I'm looking at the left hand side thinking, how can I get x on its own? There's a lot going on the left hand side. First thing you want to do is get rid of this. So multiply everything by 5, divide everything by 2. You want to get the bracket on its own. So we'd have 4 plus x to the power of a half. If we multiply up by 5, divide by 2, so that would be minus a half. Multiply by 5, divide by 2, so that would become plus 5 over 2. Okay, that's the square root, isn't it? So how do you get rid of the square root? You square both sides. Okay, so that would be 4 plus 5x. Remember, when you're applying a function, you don't square them separately. We are squaring this equation. We're squaring the left hand side, we're squaring the right hand side. So the whole thing would be squared. So all that stuff would be in that bracket squared. And then the last thing, subtract the 4, divide by the 5. So 5x would equal that bracket squared minus 4. Divide everything by 5, so x would equal 1/5. Open up a big bracket. Inside that bracket we've got minus a half, 1 plus t to the minus 1 plus 5 over 2. That bracket is being squared, minus 4. So all that stuff in that bracket is squared. You then subtract the 4, and then you divide everything by 5. Okay, we could probably do a little bit with this, but one thing I definitely wouldn't do, like you don't want to square that bracket out, just leave it as a bracket squared. Okay. The only difference from the one on the sheet is that see, instead of writing this as a bracket to the power minus 1, they've just put it on the bottom. And it's like 1 plus t on the denominator. Okay. Fairly long video there, but that's like the whole topic of differential equations done there. So obviously you're going to need to practice these. So if you have a look at exercise 2, there's a good selection of questions there. Some of the later on questions have got some fairly awkward integrals, but we've done a lot on integration in the last couple of weeks. So I would try my best to do as much of exercise 2 as possible. Use the word solutions and drop us an email if you're not sure, guys. Okay, thank you. Enjoy.